Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video we are going to troubleshoot this network. So see, this is my topology for today. In my topology I have three routers. Router 1, which is the hub router, you can say headquarter router, main office router, right? Data center router. And router 2 and router 3 are spoke routers. Like router 2 is spoke 1 and router 3 is spoke 2. So these are branch offices routers. Let's suppose we have main headquarter in India and I have two spokes, two branch offices, with let's say one in US and one in Australia. And then guys, after configuring this network, we have some issue here. What is the issue? See, problem is branch offices are not able to communicate with each other, or you can say spoke 1 and spoke 2 users are not able to communicate with each other, and as a network engineer you need to troubleshoot it. So first we will verify the issue. After that we will see how we can troubleshoot it, how we can fix the issue. Now guys, see, on spoke 1 means on router number 2 we have some subnets. So these are internal subnet on router number 2. Why we have multiple subnets? Let's suppose we have three department here, right? In branch 1 we have three department: HR department, sales department, and IT department. In the same way, in the branch 2 means spoke 2 means router 3 have some internal subnets. These are 30.1.1.0/24, 30.1.2.0/24, 30.1.3.0/24. And again we have some departments here in branch 2, like let's say admin department, servers department, or we have server in the headquarter. So let's say admin department, then HR department, then finance department, right? And in the headquarter again we have three subnets. So suppose here we have three department like servers. In one floor or in one building we have some servers, then we have some IT people, then we have some here let's say engineering departments, right, users. So issue over here is these subnets are not able to communicate with this subnet, means branch 1 and branch 2 are not able to communicate with each other. Now guys, let me verify the issue. So see, I have access of these all devices in secure CRT R1, R2, R3. On router number 1, I'm going to check am I able to ping branch offices user. So let me ping 20.1.1.1 and source 10.1.1.1 numer ping. So see, ping is working, right? Means headquarter users are able to communicate with branch 1. Let me check branch 2, ping 30.1.1.1 and source 10.1.1.1. 30 is connected on router number 3, you can see on spoke 2. So let me check this communication. So yes, you can see, means headquarter users are able to communicate with spoke 1 as well as spoke 2, means branch 1 and branch 2. Now let me take you to branch offices router, like on router number 2. On router number 2 I'm going to ping let's say 10.1.2.1, means headquarter user from 20.1.2.1. So you can see ping is working. I'm able to ping headquarter users. Now I am going to ping other branch office user. So let me ping 30.1.1.1 and say source 20.1.1.1. and see guys, this time ping is not working, so we have issue. Now let me verify the issue, and after that we are going to troubleshoot it. Guys, in last video also we have discussed how to troubleshoot routing issue. In the same topology, in last video we had fixed the issue of split horizon. Like on router number 1, split horizon was enabled. Because of that, hub router was not advertising branch offices prefixes to remote routers, like to branch routers. What I am saying, if split horizon is enabled on this interface, then what will happen? Router 2 will advertise this subnet to router number 1, but router 1 will not advertise those to router number 3, right? Because it will not send same update message from the receiving interface. This is rule of split horizon, right? So that's why you have to disable the split horizon, so that router 1 can forward all learn routes from router number 2 to router number 3. What I am saying, router 1 should advertise all received route from router number 2 to router number 3. In the same way, router 1 should advertise all received route from router number 3 to router number 2. So that's why we need to disable speed horizon here, and in the last video we had disabled the speed horizon. So today again I am going to check speed horizon, like speed horizon is enabled or disabled. Before that, here on daughter number 2 you can check routing table or branch miss spoke 1 daughter, so IP route EAGRP, and you can see I am learning only headquarter routes, right? Router 2 means spoke 1 router is learning only all subnets of headquarter, right? Router 1 don't have remote branch subnets like spoke 2 subnets which are connected with spoke 2. So this is the issue, and this issue can be because of speed horizon if speed horizon is enabled on router number 1. In the same way you can check routing table of router 3 also, so IP route EAGRP. See, same thing, router 3 have also all subnets of headquarter, but router 3 don't have any subnet of spoke 1. So now guys, on router number 1, let me check speed horizon. Speed horizon must be disabled here, so say so IP EAGRP interface F0/0 and detail like this, no, like this. So IP EAGRP interface detail fast ethernet 0/0. So yes, here you can see speed horizon is disabled. So fine, if speed horizon is disabled, then why I am not learning, why spoke routers are not learning other branch routes, right? So IP route EAGRP, why we are not learning 30 network here? So hope issue is clear guys, and we have checked the speed horizon. Speed horizon is also disabled. Now how to troubleshoot this scenario? Now guys, we have verified that EAGRP is enabled on all routers because we have some received route from EAGRP on each router. That means EAGRP is enabled, right? Now what ES number I am using? So IP protocol. So EAGRP ES number is 10. Now question is why we don't have route here. First of all, if route is not available in the routing table, then you should check topology table that route is available in the topology table or not. Like on router number 1 you can see, so IP EAGRP topology. See, we have all subnets of spoke 1 means branch 1, as well as we have all subnets of spoke 2 means branch 2. In the same way we should verify the topology table of router 2 also. Topology table should be identical same, right, on all router. So on router number 2, so IP EAGRP topology, but here you can see on router number 2 we have all subnets of headquarter, all 10 networks are there, as well as all directly connected networks are there, means 20 networks are there, but we don't have 30 networks. 30 subnets are not present in the topology table of router 2. In the same way on router number 3 also we can check topology table, so IP EAGRP topology. So same thing over here as well. On router number 3 also you can see we have all subnets of headquarter, and then we have all directly connected networks, all directly connected subnets. So it is very clear that router 1 is not advertising, right, remote branch subnets, right? Or guys, if you want to verify the filtering, like if router 2 or router 3 is filtering the route, simply you can run command so IP protocol. So IP protocol, so you can see here outgoing update filter list for all interfaces is not set, as well as for incoming update filter list for all interfaces is not set. So filtering is not there. Even you can check on interface as well. So run interface F0/0. So you can see on this interface only IP addresses are enabled, right? On router number 3, so IP protocol. So on router number 3 also you can see there is no any filtering, and so run interface F0/0. No, no any filtering. Then on router number 1, so IP protocol. On router number 1 also you can see no filtering, right? And so run interface F0/0. So on this interface, speech horizon is disabled, then IP address is running. That's it. This is the configuration on this interface. Now there is no filtering. EIGRP is also working fine. Speech horizon is also disabled on hub router. Then also why we don't have remote branch routes on other branch router, right? Like on router 2, why we don't have 30 networks, and on router number 3, why we don't have 20 networks. So guys, what I can do from the router number 2, I can check the neighbors. Which type of neighbors router 1 is of router 2. Like on router number 1, you can see so IP EIGRP neighbor. So router 1 have 2 neighbor here. Router 2 have 1 neighbor. So IP EIGRP neighbor with router number 1. And again router 3, so IP EIGRP neighbor have 1 neighbor. So we have EIGRP neighborship between router 1 and router 2, as well as between router 1 and router 3. We don't have EIGRP neighborship here, right? So router 3 will learn these 20 subnets via hub router, right? In the same way, router 2 will learn all 30 subnets via hub router, correct? So now I am going to verify which type of neighbor these are, right? Means which type of neighbor router 1 is of router 2 and which type of neighbor router 1 is of router 3. Because in the EIGRP we have multiple types of routers, guys, right? So let me do one thing. Let me take you to router number 1, and this is the one command to check neighbor. Now I am going to check detailed information of neighbor. So what I can say, so IP EIGRP neighbor detailed on fast ethernet 0/0. Show me the all neighbor on fast ethernet 0/0 in detailed. So you can see first neighbor is 192.168.10.3, means router number 3. And which type of neighbor it is? It is a static neighbor, right? See SRTT time, hold time, interface, RTO time, queue count, and sequence number. After that, topology ID from peer is 0, and other neighbor is, guys, 192.168.10.0. This is the first neighbor, this is the second number. See the sequence number of neighbors. So this is the first neighbor, 192.168.10.2, means router number 2, spoke 1, right? And both are static neighbor. Fine, here everything looks good on router number 1. Now let me take you to router number 2. On router number 2, so IP EIGRP neighbor detailed and fast ethernet 0/0. Show me the detailed information of neighbor on fast ethernet 0/0. So there is only one neighbor. Neighbor IP address is 192.168.10.1 on fast ethernet 0/0. Hold on time, uptime, SRTT, RTO, QCon, sequence number, then static neighbor. But see the issue, guys. On router number 1, on router number 2, stub peer advertising, means this neighbor is the stub neighbor. That means router 1 is a stub router. Now this is the issue. Router 1 is configured as stub. Guys, in this scenario, in the hub and spoke topology, your spoke router should be configured as stub, not hub router, but should configured as stub. If hub router is the stub router, then there will be issues, right? So here you can see router 1 means 192.168.10.1 is a stub neighbor, and a stub neighbor will advertise which type of network? Connected summary routes. So router 1 is going to only advertise their connected networks, right? So okay, now issue is cleared, and router number 1, even you can run command show IP protocol. So IP protocol. So let me check here, am I able to see? Right, on router number 2, so IP protocol. Right, here we don't have stub information, but on router number 1 you can see stub, connected, and summary. That means this router is configured as a stub router, will advertise only connected networks. Fine. And now what next command we can run here? Simply we can check all configurations. So run section EAGRP. So you can see guys here, this is the incorrect command. Where is the incorrect command? Here. EAGRP stub connected summary. This command should be enabled on spoke routers, right? To reduce the query, to reduce the EAGRP updates, right? If you don't know the concept of EAGRP stub router, please let me know in the comment section. I will make one separate video on stub because it is very important, guys. In hub and spoke topology, you have to configure all spoke routers as a hub router, right? You have to configure spoke router as a hub router for the better efficiency, for the better performance, to reduce the queries, updates. But by mistaken, engineer have configured stub on router number 1, and this is the issue, because if router 1 is stub router, so stub router only sends update about its connected network, right? Or even while configuring stub, we can define which type of route this router should advertise, right? So a stub router only advertise connected networks. So router 1 is the stub router. That means router 1 will advertise only these network to router number 2 and to router number 3 to their neighbors. Correct? This is the issue. But what I want, router 1 should also advertise received route, like received route from router number 2 to router number 3, and received route from router number 3 to router number 2. Right? So if router 1 is the stub router, then router 1 will advertise only connected network and does not propagate other routers query. Even if let's say 30 network will goes down on router number 2, if 30 network will goes down, router 2 will generate query message to their neighbor query, but as router 1 is configured as stub, it will not send that query to router number 3. It will not send that query to router number 3. So if R1 is a stub router, then it will not share any received update, right? Received update means received update from router number 2 and router number 3. So router 1 is not going to advertise received routes to their neighbor, received update to their neighbor. R1 will only advertise its directly connected routes and would not propagate the route learned from R2 and R3. And you can say vice versa, right? Will not advertise routes learned from R2 and R3. So now see, problem is clear, and you can verify it on router number 3 also. Like on router number 2, we have verified that router 2 have one stub neighbor, right? Router 2 have a stub router and advertising connected network. On router number 3 also, so IP EAGRP neighbor detailed and then fast Ethernet 0/0. So you can see stub peer advertising connected summary routes. Now it is clear to you. Again, if you have issue with the concept of a stub router, please let me know in the comment section. I will try to upload video as soon as possible. Now guys, we need to fix it. So how to fix it? Simply on router number 1, I can remove this command, router EAGRP s number 10, and do so run section EAGRP, section EAGRP. So you can see this command, I have to remove this command here. Say no to this command. Right? Now you can see EAGRP neighborship has resynchronized. Now again let me check router 2. On router number 2, so IP EAGRP neighbor detailed on fast Ethernet 0/0. Now you can see neighbor is not a stub router, peer is not a stub this time. On router number 3 also, so IP EAGRP neighbor detail fast Ethernet 0/0, right? This neighbor is not a stub neighbor. And now if you will check topology table of branch office's router like router 2, so IP EAGRP topology. So now you can see this router is receiving other branch subnets, right? So now router 2 is advertising received prefix as well. Router 1 is advertising received prefixes as well from router 2 and router 3. Now so IP route EAGRP. So now you can see we have all spoke to subnets, right? In the same way on router number 3, so IP route EAGRP, we have all headquarters subnets as well as all branch 1 subnets, means spoke 1 subnets, right? Now you can verify the connectivity. Ping 30.1.1.1 and source 20.1.1.1. Now you can see ping is working. Even I can ping headquarter 10.1.1.1 and source 20.1.1.1. See, now all branch offices users are also able to communicate with each other, as well as all branch users are able to communicate with headquarter users, right? Maybe we have some servers in headquarters. So guys, now those all servers are reachable from branch offices. But now in EIGRP, this topology is not efficient. Reason? Because of query propagation. Try to understand. See, on all routers, what I am going to do, I am going to debug I debug EIGRP packets, and let's say query and reply, right? On router number 2 also debug EIGRP packets, query and reply. And on router number 3 also debug EIGRP packets, query and reply. Now what I am going to do, I am going to down any branch subnet. Like on router number 3, let me down loopback 1. So interface loopback 1, let me check on which interface I am running 30 subnet. So IP interface brief, exclude unassign. So loopback 1 2 3. Okay, now I am going to down any loopback here. Interface loopback 1, let's say shut down. What will happen? Once this interface will goes down, router 3 is going to generate query message to their neighbor, means to router number 1. Router 1 will not generate reply. First router 1 will send that query to router number 2, right? Then router 2 is going to generate reply. Reply can be positive or negative. If router 2 have alternate path, then it will generate positive reply, otherwise it will generate negative reply. If router 1 have 1000 number of neighbors, means there are 1000 branch offices, spoke routers. So router 1 is going to forward that query message to all 1000 neighbors, and it will wait for the reply message. If router 1 will not get reply within the active time, then router 1 is going to break the neighborship. Then router 1 is going to break the neighborship with their all remote users, remote neighbors. Then so to reduce this issue, because see, who is advertising 30 network to router number 2? Router 1 only, right? Router 3 is advertising these all submit to router 1, and then router 1 is advertising to router 2. So router 1 should not generate query message for the same network, right? So as these routers are edge router, right, non-transit router, we should enable stub here. We should enable stub, right? And if this topology is full mesh topology, then router 3 is going to generate query to their other neighbor also, means to router number 2 also. So now let me show you the query messages here. So we have only 3 routers in this scenario. See, this router have generated query. See the messages, it have exchanged lots of messages. On router number 1 also you can see, right? On router number 2 also you can see. So guys, this topology is very small, right? So even we have lots of query flooding in this scenario. But if topology is large, right, then we will have lots of query flooding, right? So first, when network will goes down, router 3 will generate one query message. You can see generating a query, right? And then after that it will send from F0/0, sending query on fast Ethernet 0/0. So router 3 have sent query to router number 1. Router 1 received query on F0/0. After that it is generating query on F0/0. Then it will send query to sending query on fast Ethernet 0/0. After that it will receive reply message from the neighbor. Received reply. After that it will generate again reply message. Then it will send reply message to router number 3. So when router, a spoke router will generate reply, then hub router is going to reply to other spoke router, means to router number 3. If a spoke router will not generate reply message, then your EIGRP network will become unstable, right? Then router 1 is going to break the neighborship. And guys, as you know, whenever routers will break the neighborship, it will encapsulate and decapsulate lots of messages, so performance will goes down. So for the better performance, what we can do, we can enable a stub on spoke routers, right? So let me do one thing. Let me now configure the stub. Here I am going to run no set command again, and now let me configure router 2 and router 3 as stub router. So go to router number 2 and config T router EIGRP as number 10 EIGRP stub, and then see which type of network you want to advertise. So as these are stub router, it should only advertise connected network, right? They're directly connected subnets. So say connected. Now router 2 will only advertise their directly connected networks, and we need to do same thing on router number 3 also. Router EIGRP as number 10 EIGRP stub and say connected. Now again what I am going to do, I am going to down one loopback interface on router number 3, and see this time what will happen. Interface loopback 1 and say shut down. See, router 3 have generated the query message, right? And it have sent from fast Ethernet 0/0, and then it have received the reply message. That's it, right? Router 2 have generated query to router 1, and then router 2 have generated the reply message. See, on router number 2, also we have query message. Why we have query message here now? Okay, router 2 will also generate query message because it will lose that network. But this time router 1 is not going to send query to router number 2, right? So see, router 1 is receiving query message and then sending reply message. This time router 1 is not sending query to router number 2, to their other spoke router, right? To other neighbor. Then again it have received the query, it have generated the reply, sending reply message. So this is how we can reduce the query. No set. And now show IP route EIGRP. See, EIGRP table is fine. We have all subnets on router number 2 also. So IP route EIGRP. We have all subnets, and on router number 1 also. So IP route EIGRP. Now the EIGRP network is, guys, stable, right? Now I can save the configuration, and then you can verify the connectivity. Ping 20.1.1.1 source 10.1.1.1. Ping is working. On router number 2, ping 30.1.1.1 source 20.1.1.1. See, ping is working, right? And how ping is working? Trace route 30.1.1.1 and source 20.1.1.1 numeric. So traffic is going via hub router headquarter. Reason, show IP route EIGRP, because see the next hop IP address for all 30 prefixes, right? Router 1 192.168.10.1. So router 1 is updating the next hop IP address. If you want that this is remote sorry spoke users can communicate directly, like spoke 1 and spoke 2 should be able to communicate directly via internet, right? But it should share EIGRP update message via hub router. What we can do, we can disable next hop self command on router number 1. So guys, on router number 1 by default one command is running, interface f0/0 IP next hop self for EIGRPS number 10. By default this command is enabled. I'm going to say no to this command, right? Again, EIGRP neighborship has resynchronized. Now go to router number 2 and see, check the routing table. So IP route EIGRP. Now you can see all 30 subnets are reachable directly. Next hop IP address is 10.3, which is IP address of router 3. So now if I will trace route, so you can see traffic is going directly through internet. So guys, this was a small troubleshooting, like you can say routing troubleshooting. If you have learned something from this video, please hit on like button. If you have any question, query, please let me know in the comment section. If this video is helpful for you and you want more videos like this, please type yes in the comment section. Your yes will motivate me to make more videos like this. Once you will type yes in the comment section, I will get to know that these videos are helpful for you. Fine. And guys, if you are looking for any live training, please visit pmnetworking.in. We are starting CCNA 200301 batch soon, right? So if you are looking for any live training, you can enroll yourself and then we can meet live through Zoom. That's all for today. Thanks for watching. Bye bye. Thanks for watching.